This video is about an overview of hypothesis testing, where I will be discussing different concepts that are involved in the hypothesis testing procedure. Whenever we perform hypothesis testing, there are always two hypotheses that are involved. The first one is the null hypothesis, which is usually denoted by a capital letter H and a subscript of 0. This is a statement of the basic proposition being tested. This statement generally represents the status quo and is not rejected unless there is convincing sample evidence that it is false. So this is a mathematical equation that represents what we currently believe in. And this is given the benefit of the doubt, which means that we assume that this is the correct statement unless there is evidence that proves otherwise. The other hypothesis is called the alternative or the research hypothesis, which is usually expressed by a capital letter H and a subscript of either small letter a or the number 1. The alternative or the research hypothesis is the opposite of the null hypothesis, and this is a statement that will be accepted only if there is convincing sample evidence that it is true. Unlike the null hypothesis, the alternative or the research hypothesis is assigned the burden of proof, which means that we will only believe this if there is evidence that supports this. So in the trash bag case, suppose that an independent laboratory has tested trash bags and has found that no 30-gallon bags on the market have a mean breaking strength of more than 50 pounds. The producer of the new trash bag feels sure that its 30-gallon bag will be the strongest such bag on the market if the new trash bag's mean breaking strength can be shown to be greater than 50 pounds. The mean of the sample of 40 trash bag breaking strengths is 50.575 pounds. Assume that the standard deviation is 1.65. So in this particular example, our objective is to determine if the average breaking strength of the trash bags can be shown to be greater than 50 pounds. This is what we are trying to show, and this is also what the sample of 40 trash bags is suggesting, that the average is indeed greater than 50. Although this is already greater than 50, remember this is only from a sample of 40, so we are not yet sure if the average for all the trash bags, so the entire population of all trash bags, we don't know if the average of that is also greater than 50. That's why we will perform hypothesis testing. So in this particular example, our alternative hypothesis, the objective that we are trying to support, or the objective that our sample is also suggesting, is that the average is greater than 50 pounds. And therefore, the null hypothesis should be the opposite, which is that the average is less than or equal to 50 pounds. So again, the hypotheses are mathematical representations of those two different statements. The null hypothesis is the status quo. So currently, our assumption is that the average for all the trash bags is less than or equal to 50 pounds. And we will try to see if we can generalize for all the trash bags that the average is now greater than 50 pounds. In the payment time case, a consulting firm recently installed a new electronic billing system, and the company hopes to decrease the bill payment time by more than 50%. Using the old system, the average bill payment time was at least 39 days. Therefore, the company believes that the new system will reduce payment time to less than 19.5 days. From a sample of 65 payment times, the average was 18.11 days, and assume that the population's standard deviation of payment times is 4.2 days. So in this particular example, now our objective is to try to determine if we can conclude that the average payment time under the new system is now less than 19.5 days. Therefore, that will be our alternative or our research hypothesis, which is mu less than 19.5 days. As such, the null hypothesis will be the opposite, which is mu greater than or equal to 19.5 days. So again, these are the two hypotheses that are involved in this case. So our null hypothesis or our status quo is that we believe that the average is greater than or equal to 19.5. And we will try to see if the average for the entire population can be said to be less than 19.5 days now in the new system. In this third case, a candy company annually markets a special 18-ounce box of assorted chocolates to large retail stores for Valentine's Day. This year, the company made an extra special box with a new assortment of chocolates. The company projects that there will be a 10% increase in sales. Last year, the mean orders of the stores was 300 boxes, and the company wants to know whether they should prepare for a 10% increase in sales or not. From a sample of 100 stores, the average was 326 boxes. Assume that population standard is 40 boxes. So in this particular case, our objective is to determine if the company should prepare for a 10% increase from the previous year. So if the average from the previous year is 300, basically we want to know now if the average will be 330 or a 10% increase from last year or not. So now what we want to know is if the average is equal to 330 or not equal to 330. Now, as we have seen earlier, the equality sign is always placed in the null hypothesis because that is the convention. And therefore, in this particular example, we will also make sure that the null hypothesis will contain the equality sign. Now, compared to the previous two examples, in this particular case, we do not really want to know if the average should be less than or greater than 330 boxes. We just want to know if it should be exactly 330 or not 330. And therefore, the null hypothesis should state that the mu, the population mean, is equal to 330, and that the alternative hypothesis is that the mean is not equal to 330. Now, these three different cases or examples represent the three types of alternative hypotheses that are possible whenever we perform hypothesis testing. So the first one represents a one-sided greater than alternative because the alternative hypothesis uses a greater than inequality sign. Meanwhile, the second example uses a one-sided less than alternative hypothesis because the alternative hypothesis used the less than inequality sign. And finally, the third example represents a two-sided not equal to alternative because the alternative hypothesis used an inequality or a not equal to sign. So those are three different alternative hypotheses that are possible to be tested in hypothesis testing. And later on, we will see the implications of these different types of hypotheses in terms of the computations in hypothesis testing. But for now, these are the three types of hypotheses that we can test later. Now, in hypothesis testing, there are strictly two types of decisions that are possible. We only make either of these two decisions, and no other decisions are acceptable other than these two. So the first decision for hypothesis testing is we reject the null hypothesis, which is only made if there is sufficient evidence to say that the null hypothesis is no longer true. So if our evidence is overwhelming that supports the alternative hypothesis, we make the decision that we reject the null hypothesis. We reject the null hypothesis because this is no longer true. Our evidence now supports the alternative hypothesis. Now, we say that we reject the null hypothesis instead of accept the alternative hypothesis because this is a weaker statement. When we accept the alternative hypothesis, there is an implication that we are 100% sure that the alternative hypothesis is correct. But that is not the case in hypothesis testing. Remember, in hypothesis testing, our data is only from a sample. Our data is only based on an incomplete set of information, and therefore there is no guarantee that the alternative hypothesis applies to the entire population. It's just that based on our evaluation, we have enough evidence that supports the alternative hypothesis, but we are not 100% sure that the alternative hypothesis is correct. That's why we prefer to use the statement reject the alternative hypothesis. We're just saying that, yes, we have evidence that supports the alternative hypothesis, but we are not 100% sure that the alternative hypothesis is correct. So for now, we will reject the null hypothesis and support the alternative hypothesis. The other possible decision is do not reject the null hypothesis. And this is the decision that we make when the sample provides us information that is insufficient to support the alternative hypothesis. So let's say we have evidence that supports the alternative hypothesis, but based on our evaluation, it's insufficient, it's not enough, it's not convincing enough. And therefore, we do not reject the null hypothesis. We still assume, we still believe that the null hypothesis is the correct one because we don't have enough evidence to convince us that the alternative hypothesis is the correct statement. So we prefer to use this decision instead of accepting the null hypothesis. Because again, when we use this statement, there's an implication that we are saying that the null hypothesis is 100% sure, or that the null hypothesis is guaranteed to be sure, which again is not the case in hypothesis testing. In this case, we have some evidence, we may have some evidence that the alternative hypothesis is correct. It's just that it's not convincing enough. And therefore, we just say that we do not reject the null hypothesis. Yes, it's still possible for the alternative hypothesis to be correct. We just don't have enough evidence for now to support that. That's why we still assume that the null hypothesis is still the correct statement. So again, there are only two acceptable decisions in hypothesis testing. We either reject or do not reject the null hypothesis. And this is very much similar to what most legal systems worldwide are using. So whenever there are any legal cases that are being tried, decisions are either guilt is established beyond reasonable doubt or guilt beyond reasonable doubt is not established. And this particular decision is made if we have sufficient evidence that the accused is not innocent. So we have convincing evidence that the suspect really committed the crime. And therefore, we can say that the person is guilty beyond reasonable doubt. So this is a weaker statement than saying that the person is guilty. Because remember, we are not 100% sure that the person committed the crime, but our evaluation provides us sufficient evidence to believe that the person is guilty. Meanwhile, if the evidence is insufficient, instead of saying that the person is innocent, we just say that guilt beyond reasonable doubt is not established. Because again, we are not 100% sure that the person is innocent. It's still possible that the suspect really committed the crime. It's just that we don't have enough evidence to support that. And therefore, instead of saying that the person is innocent, we just make the safer conclusion that guilt beyond reasonable doubt is not established. Now, what is the basis for making the decision? We were saying earlier that our evaluation should tell us if the evidence is enough or not. In hypothesis testing, the basis is a test statistic. It's a computation. So a test statistic is a basis for making a decision regarding the null hypothesis. And this is the primary evidence for the hypothesis test. Now, in determining if the test statistic is as considered sufficient evidence or not, there are two methods that we can use. The first one is called the critical value method, and the other one is the p-value method. Later on, we will discuss how these two different methods differ in terms of the procedure, but whether you use this method or the other one, they will both result to the same decision. So any of these two will lead to the same conclusion. Now, every time hypothesis testing is performed, there are always two possible errors that can be committed. Remember, hypothesis testing is an inferential statistics tool, which means that we are making inferences for the entire population, even if the data is only from a sample. And therefore, there is always a possibility that our generalization is incorrect. And the error that we can commit can be categorized as either type 1 error or a type 2 error. Type 1 error happens when we reject the null hypothesis when it is true. We conclude that we have enough evidence to support the alternative hypothesis, but in reality, the alternative hypothesis is not correct. We call that a type 1 error. Now, the probability of committing a type 1 error is denoted by the Greek letter alpha, which is the same as the significance level that we were using when computing for confidence intervals. So alpha, the Greek letter alpha, is how we express the probability of committing a type 1 error. And therefore, 1 minus alpha is the probability of not making a type 1 error, which is also known as the confidence level. The type 2 error, on the other hand, happens when we fail to reject the null hypothesis when it is false. In reality, the null hypothesis is already false. In reality, the alternative hypothesis is already correct. However, we conclude that we don't have enough evidence to support the alternative hypothesis, and therefore we don't reject the null hypothesis. So we call that a type 2 error. And the probability of committing a type 2 error is denoted by a different parameter, which is the Greek letter beta. So beta is the probability of committing a type 2 error. And the complement of this, 1 minus beta, is the probability of not making a type 2 error. So the alpha and the beta are two distinct concepts. So this is not the complement of this because these are two different kinds of errors that can be committed. So here is a table that further distinguishes the two types of errors that can be committed. Again, type 1 error happens when we reject the null hypothesis when this is still true, while the type 2 error happens when we don't reject this when this is already false. And it's also possible to make correct decisions when we perform hypothesis testing. So when we reject the null hypothesis, and in reality, the null hypothesis is already false, then we make the correct decision. Or if we do not reject the null hypothesis and it turns out that the null hypothesis is still correct, then we are also making the correct decision. So as much as possible, we want to make decisions that are correct. But again, in hypothesis testing, it is unavoidable. There will always be a possibility of committing a type 1 or a type 2 error because our data is only from a sample. Here is another common example that differentiates the type 1 error from the type 2 error. So the type 1 error is also known as a false positive. You are making a positive conclusion. You're saying that something is, when in reality, it is not. Type 2 error, on the other hand, is a false negative. You are saying that something is not, when in reality, it already is. So here, when we conclude that a person is pregnant, but the person is not really pregnant, that is a type 1 error. But the type 2 error happens when we say that a person is not pregnant when the person is actually pregnant. So in the trash bag case, again, we have these hypotheses. So the null hypothesis states that the average is less than or equal to 50 pounds, and the alternative hypothesis states that the average is greater than 50 pounds. So a type 1 error happens when we reject this, when this is false. We claim that the mean breaking strength is greater than 50 pounds when it is actually not greater than 50 pounds. We conclude that the trash bag is the strongest in the market when it's actually not the strongest. So that is the type 1 error. The type 2 error, on the other hand, is again the false negative. This happens when we don't claim that the mean breaking strength is greater than 50 pounds, when in fact it is. In reality, the trash bag is actually the strongest trash bag in the market, but we don't make that statement. And again, that is your type 2 error. Now, between these two types of errors, the type 1 error seems to be more costly. Whenever we commit a type 1 error, we usually face grave, more serious consequences as compared to committing a type 2 error. In this particular example, if we claim that our trash bag is the strongest when it's actually not, there are several consequences that we can face. First, we might get sued for false advertising. Our consumers may also lose their trust in us because we are not saying a correct statement. And ultimately, our reputation might be affected because of false advertising. So, those are the possible consequences of committing this error. Meanwhile, if we commit a type 2 error, we are just not able to take advantage of the opportunity to market or to claim that our trash bag is the strongest. So there is a wasted opportunity to maximize this information because we are not making this particular statement. So between the two, a type 1 error seems to be more serious. And between the two, this type of error is the one that we should try to avoid more compared to committing a type 2 error. And again, this is also reflected in most legal systems, and that is reflected by the Blackstone principle, which states that it is better that 10 guilty men go free than that one innocent man be convicted. So in legal systems, the null hypothesis, the assumption among all suspects is that they are innocent, that they did not commit the crime. And therefore, a type 1 error in that particular case would be to conclude that a person is guilty when in reality they did not commit the crime. While a type 2 error happens when we don't say that the person is guilty, we just say that guilt beyond reasonable doubt is not established, when in reality they actually committed the crime. So again, this indirectly states that uh, committing 10 type 2 errors is still preferred compared to committing one type 1 error, which again reflects the common sentiment, the widely accepted notion that the type 1 error is more costly and should be avoided more compared to a type 2 error. And this is also why in hypothesis testing, we pay more attention to alpha instead of beta. Because alpha, again, is the probability of committing a type 1 error. And this is also the reason why we usually set alpha to a low value. So the convention for alpha is 0.05. In most disciplines, an alpha of 0.05 is the standard. But there are different values of alpha that can also be used to test different hypotheses, and we will look at them in a while. So again, we typically set alpha to 0.05, which means that there is only a 5% chance of committing type 1 error. Now, there is actually a trade-off between alpha and beta. So for a fixed sample size, if alpha is lower, beta becomes higher. And in this case, again, that is okay because we would rather have a low alpha and a high beta than the other way around because we prioritize minimizing the probability of committing a type 1 error than minimizing the chances of committing a type 2 error. Now, the convention for alpha is 5% or 0.05. But in our examples, we will be using four different values of alpha, which can also be used to make qualitative descriptions of the amount of evidence that we have. So if we can reject the null hypothesis at an alpha of 10%, we can say that the weight of our evidence is some. We have some evidence to support the alternative hypothesis. And as you decrease the value of alpha, as alpha decreases, the probability of committing a type 1 error decreases, and therefore the weight of our evidence also gets stronger. That's why if you move to an alpha of 0.05, we now have strong evidence. For an alpha of 1%, the weight of evidence is very strong. And finally, if alpha is only equal to 0.001 or 0.1%, then we have extremely strong evidence to support the alternative hypothesis. So later we will see how to test at all these four different values of alpha and how to make the appropriate interpretations in terms of the weight of evidence that is available. In hypothesis testing, there are several steps that are involved. The first one would be to state the null and the alternative hypotheses. Next would be to specify the level of alpha that we will be using to test the hypothesis. Next would be to determine the appropriate test. Later on, we will be discussing different types of tests that are available depending on what is given. So we will devote one step to determine the specific test that should be performed. And then step 4, we will decide which rejection rule we will follow. Here, we will also decide if we will use a critical value method or a p-value method in order to make a decision. Step 5 involves determining the evidence. So here we compute for the test statistic, and then using the test statistic, we will make a decision in step 6 if we will reject or not reject the null hypothesis. And then finally, we interpret the results in actual terms. Okay, we go back to the actual variables involved and then assess the practical importance of the findings of the hypothesis test.